All right, we're diving into a story that's unfolding as we speak. It connects a really mysterious object hurtling through our solar system right now, with a powerful, unexplained signal we picked up almost half a century ago.
So let's go all the way back to August 15th, 1977. A radio telescope in Ohio picks up this incredibly strong signal from deep space. It only lasted 72 seconds, but it was 30 times stronger than the background cosmic noise, and it was on a frequency that's just perfect for interstellar communication. The astronomer who discovered it was so blown away he just circled it and wrote "Wow" on the printout. And then, nothing. Silence. The signal was never heard from again, leaving us with a mystery that's now 48 years old.
Okay, now fast forward to today. We've got this interstellar object, basically a visitor from another star system, named 3I/Atlas, and it's speeding through our solar system. And just recently, Harvard astrophysicist Avi Loeb published a paper making a really shocking connection between these two events separated by 48 years and, hundreds of billions of kilometers.
This is the huge question we're digging into. What if that signal from 1977 wasn't random? What if it was an announcement? Like an interstellar calling card sent from the very same object that's now paying us a visit. Let's try and piece this cosmic detective story together.
Okay, so let's get into the details. Avi Loeb, using all the super precise orbital data we have for 3I/Atlas, did something pretty brilliant. He traced its path backward in time, rewinding the clock all the way back to August 15th, 1977.
And get this, what he found was absolutely remarkable. On that exact day, the object was right there in the very same patch of sky that the wow signal came from. The alignment is so spot on that the probability of it just being a random coincidence is only 0.6%. So, to flip that around, there's a 99.4% chance that this connection is for real.
But, the plot thickens. It's not just about where 3I was in the past. It's about what it's doing right now. Its behavior is just weird. It's defying all our expectations for a normal comet and showing off a whole series of baffling anomalies.
Avi Loeb and his team have zeroed in on 5 distinct anomalies. Now, each one of these on its own is kind of improbable, but when you put them all together, they paint a picture that is statistically almost impossible for just a random natural object. So, let's break them down.
First off, its tail is completely wrong. You know how comets have tails? They're made of dust and gas pushed away from the sun by the solar wind. But images from the Hubble telescope show 3I/Atlas has a bright glow in front of it, pointing towards the sun. It's like it has headlights. One possible explanation is that the object isn't spinning, so it's keeping one face pointed at the sun all the time, which is just super unusual for an object flying through space.
And this is a huge clue. When we look at the light coming off it, we can see it shedding pure nickel. So what's weird about that? Well, it's shedding nickel without any iron. In nature, nickel and iron are basically cosmic buddies. They're almost always found together. But separating them, that's a classic sign of industrial manufacturing, something we do right here on Earth. And then you've got the mass problem. The James Webb Telescope measured this thing losing a crazy amount of material, about 150 kilograms every single second. That's like a fire hose of gas venting into space. Normally, that would act like a tiny rocket pushing the comet and changing its trajectory. But its path hasn't budged, not one bit. And that means it must be incredibly massive, at least 5 kilometers across, which makes finding an object this big this early, well, it's a huge statistical long shot.
Okay, so we have to be fair here. The broader scientific community is, let's just say, highly skeptical. They argue that, yeah, the object is definitely strange, but there are potential natural explanations for all these weird things.
For that weird anti-tail, skeptics say, well, maybe it's just gassing out unevenly. The whole nickel without iron thing? They're suggesting some kind of super exotic chemistry, maybe a volatile molecule called nickel carbonyl, something we've literally never seen in a comet before. And its enormous size? They say, look, it could just be a statistical fluke. We haven't seen that many interstellar visitors, so maybe we just happened to find a giant one first.
And NASA's official stance, which was spelled out by lead scientist Tom Statler, is pretty clear. While 3I/Atlas is a really interesting object with some unusual quirks, the evidence overwhelmingly points to it just being a natural, though very, very strange comet.
So which is it? A 1 in a billion natural weirdo or something else entirely?
Well, we might be about to find out, because this story is unfolding right now, and the next few weeks are going to be absolutely critical.
Right now, spacecraft orbiting Mars are getting our first real close-up images. But the date to circle on your calendar is October 29th. That's when it gets closest to the Sun, but it'll be on the opposite side of the Sun, completely hidden from our view. Now, if you wanted to make a maneuver without being seen, that would be the perfect time to do it. We won't be able to see it again until December, and you can bet we'll be looking very closely to see if its path has changed.
To help kind of classify all these possibilities and the potential risk, Avi Loeb developed a framework that's now known as the Loeb scale. It's a super simple 0 to 10 system. A level 0 is just a totally normal natural comet. A level 10, that's a confirmed artificial object on a collision course with Earth.
So where does 3i Atlas sit on this scale right now? It's at a level 4. This means it's an object with multiple anomalies that are really hard to explain naturally, and it corresponds to about a 40% probability of being artificial. Now think about that. A 40% chance might not sound huge, but it's significant enough that we have to take this possibility seriously and investigate it with every tool we have.
And so, we're left at this fascinating crossroads, aren't we? Is this a 48-year-old message, a cosmic postcard, finally being delivered by some ancient artifact? Or is this just a profound lesson from the universe, reminding us that nature is and always will be far stranger and more wonderful than we can possibly imagine? The next few weeks just might hold the answer.
Welcome to the Deep Dive. Today we're tackling something, well, truly extraordinary, the interstellar object 3i Atlas.
It's definitely got the scientific community buzzing and pretty sharply divided.
Right. And our mission here is to unpack why. Is it just a really weird comet, maybe the strangest one we've ever seen?
Or is it potentially something else, something artificial? The data we have from orbital mechanics to, detailed spectra from JWST, it's pushing us to ask that question.
We've got calculations from Avi Loeb at Harvard, telescope data from Hubble, JWST, the VLT, a lot to dig into.
Exactly. We're going to walk through the evidence step by step to really understand why 3i Atlas is such a profound puzzle.
Okay, so let's start, maybe not with Atlas itself, but with a mystery from nearly 50 years ago, the WOW signal. Take us back to 1977.
August 15th, 1977. The Big Ear radio telescope in Ohio picks up this incredibly powerful radio signal.
How powerful?
Something like 30 times stronger than the background cosmic noise. A massive spike. And it lasted for a very specific duration.
72 seconds. Right?
Exactly 72 seconds. Which is precisely how long you'd expect a signal from a fixed point in space to stay in the telescope's view as the Earth rotated.
Okay, so targeted, powerful, and temporary. But the frequency was key too.
That's arguably the most tantalizing part. It was at 1420 megahertz.
The hydrogen line.
Precisely, the neutral hydrogen frequency. Hydrogen's the most common element, so if you wanted to send a deliberate signal across the cosmos, that's like the universal calling card.
The logical channel to use. Yeah. Someone saw the printout and literally wrote, wow, next to it.
Yeah, can you imagine realizing this might be it, but then nothing. It never repeated. It just became this famous astronomical boast.
So for decades, it's this unexplained anomaly. How does Avi Loeb connect that signal from 1977 to 3i Atlas showing up now?
There's some pretty intensive orbital mechanics calculations. 3i Atlas is on this hyperbolic trajectory, meaning it's just passing through, not orbiting our sun.
Right, it's an interstellar visitor.
So Loeb's team traced its path backward in time, and on August 15th, 1977, the day the WOW signal was detected.
Where was 3i Atlas?
It was about 600 astronomical units away. That's way out there, deep in the outer solar system, but heading inwards at about 60 kilometers per second.
Okay, so it was in the solar system, broadly speaking.
Huh.
But the alignment, the WOW signal, came from Sagittarius.
This is the bit that really raises eyebrows. The signal's origin was pinpointed to a specific celestial coordinate, roughly 291 degrees right ascension.
And Atlas's calculated position back then
Was less than 10 degrees away from that point in the sky.
less than 10 degrees, which sounds like a fair bit, but on the scale of the entire sky.
It's incredibly close. Think about how vast the sky is. The probability of a random incoming object happening to be aligned that closely with that specific signal source on that specific date.
What are the odds?
Loeb calculated it at about 0.6%, just over 0.5% chance of it being a coincidence.
Wow. Okay, so flipping that, there's a 99.4% chance statistically that 3i Atlas was the source.
That's what the math suggests. And think about the implication for a signal to be that strong from 600 AU away.
It would need a serious power source.
A huge amount of power. Estimates are between 0.5 gigawatt and 2 gigawatts. That's the output of a large nuclear power plant on Earth.
Okay. That definitely leans away from random cosmic noise.
It suggests something powerful and potentially something deliberate.
So we have this potential announcement decades ago. But now that 3 Atlas is here, its behavior is also anomalous, right? Loeb points out 5 specific things that just don't fit the normal comet picture.
That's right, 5 anomalies. Each one on its own might be improbable. But taken together, they paint a very strange picture. Let's start with the orbit itself. Anomaly number 1. The trajectory alignment.
We know it's interstellar and it's moving retrograde.
Yes, moving backward compared to the planets, which is odd, but plausible for an interstellar object. The really weird part is its inclination.
Inclination. You mean how tilted its orbit is?
Exactly. It aligns almost perfectly with the ecliptic plane.
Remind us what the ecliptic plane is.
Think of it as the flat disk, the racetrack, where all the major planets orbit the sun. Most random interstellar objects should come in at much wilder angles, maybe 40, 50 degrees inclination.
On Atlas.
Just 5 degrees is basically flying level with the planets. The probability of that happening randomly, about 1 in 500.
Okay, 1 in 500 for the alignment. What's anomaly number 2?
The timing. Its trajectory seems almost designed for planetary encounters.
How so?
It's timed such that its path crosses near the orbits of Mars, Venus, and Jupiter. In fact, it just had a relatively close pass by Mars on October 3rd, about 29 million kilometers.
That's cosmically close.
It is. And the odds of a random arrival time allowing for such close passes near multiple planets, that calculation comes out to roughly 1 in 20,000.
Okay, now we're multiplying these probabilities. 1 in 500 times 1 in 20,000. The odds of this being natural are plummeting. What's anomaly 3?
This one's about timing too, but in a different way. Let's call it the disappearing act.
That's intriguing.
3i Atlas reaches perihelion, its closest point to the sun, on October 29th, 2025.
Right, when it should be most active, heated up, shedding gas and dust.
Exactly. But at that precise moment of maximum activity, it will be positioned directly behind the sun as seen from Earth, completely hidden from our view for several weeks.
So peak activity happens when we absolutely cannot see it.
Precisely. And from an orbital mechanics perspective, perihelion is the most efficient time to make a significant trajectory change, like using a thruster or, say, solar radiation pressure.
Performing a maneuver while hidden by the sun itself.
Yeah.
That's convenient. If it's intentional.
It's certainly optimal timing for an unobserved maneuver. Now, Anomaly 4 is about its appearance, what it actually looks like.
The anti-tail.
Yeah, that's a good way to put it. Normal comets develop tails of gas and dust that point away from the sun, pushed by solar wind and radiation pressure.
We've all seen the pictures.
Right. But Hubble images of 3 Atlas show dust concentrated primarily in front of the nucleus, facing towards the sun, almost like headlights.
Headlights instead of a tail. What could cause that?
It strongly suggests the object isn't tumbling randomly like a typical comet nucleus. It might be non-spinning or perhaps actively maintaining a fixed orientation relative to the sun. Very unusual behavior.
Okay, that's 4 anomalies piled up. What's the 5th? You mentioned a mass problem.
This one might be the most compelling physical contradiction. We know from observations, especially with the James Webb Space Telescope, that 3i Atlas is outgassing significantly.
Losing mass. How much?
Around 150 kilograms per second. Think of it like a massive, continuous rocket thruster firing off one side.
Okay, so if you have that much thrust pushing on a comet.
You should absolutely see it affecting the comet's path. It should cause what's called non-gravitational acceleration, tiny deviations from a purely gravity-dictated orbit.
Like a sailboat being pushed by wind, not just currents.
Good analogy. But here's the kicker. Loeb's team and others have looked very carefully. There is zero measurable non-gravitational acceleration. It's sticking perfectly to its gravitational path.
Despite shedding 150 kilos a second. How is that possible?
There's really only one viable explanation within physics. The object must be incredibly massive. So massive that the thrust from the outgassing is simply too small to nudge it noticeably.
It's too heavy to be pushed around by its own exhaust.
Exactly. The calculations put the minimum required mass at around 33 billion tons. To have that much mass, it would likely need a diameter of at least 5 kilometers.
5 kilometers. That's big for an interstellar visitor, isn't it?
Yeah.
I thought Oumuamua and Borisov were smaller.
Much smaller. And this is the statistical bombshell. In space, small objects are exponentially more common than large ones. Dust is everywhere, kilometer-sized objects are rare. Finding something 5 kilometers across is only the third interstellar object we've ever detected.
The odds must be tiny.
Astronomically low. It's like pulling 3 lottery tickets ever and hitting the super jackpot on the third one. Unless that size isn't random. Unless it's large for a reason, maybe structure, shielding, resource capacity.
Okay, the behavior, the orbit, the size. It all screams unusual. So what about its composition? What is it actually made of? This seems like where we might find a smoking gun.
And the chemical data is really striking. We have readings from both JWST and the Very Large Telescope in Chile.
What did JWST find?
It found a composition that's basically inverted compared to typical solar system comets. It's about 95% carbon dioxide gas and only 5% water vapor.
Whereas our comets are mostly water ice, right?
Overwhelmingly water-rich, yes. Now, the counterargument is maybe it formed in a very CO2-rich environment far away, or maybe billions of years of cosmic rays cooked the outer layers, leaving mostly CO2. It's unusual, but perhaps not impossible naturally.
Okay. Weird chemistry, but maybe explainable. What did the VLT add?
The VLT looked at metallic elements, and this is where it gets really hard to explain naturally. It detected strong emissions from neutral nickel.
Okay, nickel exists in space.
It does, but here's the thing. It found strong nickel signals, but no detectable iron lines. None.
Nickel without iron. Is that possible?
Not naturally, as far as we understand astrophysics. Nickel and iron are cosmic siblings. They're forged together in the hearts of supernovae. Every asteroid, every meteorite, every rocky body we've ever analyzed has nickel and iron always together because that's how nature makes them.
They're intrinsically linked.
Inextricably. Finding significant nickel with no associated iron in a natural object. It's like finding a forest with trees but no wood. It just doesn't align with the known processes of stellar nucleosynthesis or planetary formation.
Well, if it's not natural, what's the alternative?
Well, on Earth, we do separate nickel from iron. We do it industrially. Processes like the MON process use nickel carbonyl gas specifically to isolate pure nickel.
You're saying the chemical signature resembles an industrial byproduct?
The lack of iron alongside the nickel is a recognized technosignature, a potential sign of artificial manufacturing. It's arguably the single strongest piece of evidence pointing away from a purely natural origin.
Wow. Okay, that's a significant claim.
Yeah.
So, putting all this together, the
Wow.
signal link, the 5 orbital and physical anomalies, the nickel-iron separation, where does this object sit now in terms of scientific assessment? You mentioned the Loeb scale.
Right. Avi Loeb proposed a scale from 0 to 10 to classify potential non-terrestrial objects based on the evidence. 0 is definitely natural, 10 is confirmed artificial and potentially hazardous.
And 3I Atlas.
It's currently rated at level 4.
What does level 4 mean?
It means multiple anomalies, difficult to explain naturally, possible artificial origins suggested, but not confirmed. It's essentially the scientific framework acknowledging, okay, our standard comet explanation doesn't fit all the facts here, something else might be going on.
Level 4 is a big step. It forces us to consider some pretty profound ideas like the dark forest hypothesis.
Exactly. The idea that maybe advanced civilizations stay quiet because broadcasting your existence is dangerous. If Atlas is artificial, it's decades of silent approach followed by these odd maneuvers. Well, it fits an unsettling narrative for some. Its purpose would be completely unknown.
And this has, predictably, caused a huge debate in the scientific community.
Oh, absolutely. It's become quite polarized. There's a strong contingent of skeptics.
What's their main argument?
Primarily Occam's razor. The simplest explanation is usually the best. They argue the simplest explanation is still unusual comet. They point to the fact it does have a coma. It is outgassing volatiles like CO2 and even cyanide, which are seen in comets. They accuse Loeb of pushing a fringe hypothesis and ignoring the simplest fit.
But does unusual comet actually explain all the data? The nickel, the lack of acceleration, the orbital alignment.
And that's Loeb's counterargument. He says Occam's razor only works if the simplest explanation actually accounts for all the observed facts. Ignoring the anomalies doesn't make the comet explanation simpler, it just makes it incomplete.
So the argument is whether weird comet is simpler than artifact, when weird comet fails to explain several key observations.
Precisely. Loeb argues that science must investigate anomalies rigorously, without prejudice against potentially uncomfortable conclusions, like technology. Ignoring data because it doesn't fit the preferred model isn't good science.
It's a fundamental disagreement about how to apply scientific principles when faced with extreme outliers. So, where do we go from here? What are the next crucial steps or observation windows?
Well, we just passed one critical point. The Mars flyby on October 3rd. NASA's Mars Reconnaissance Orbiter used its HiRISE camera to get close-up data.
What are they hoping to see in that data?
Structure, mainly. Any sign of non-natural shapes, symmetry. Also, any evidence of smaller objects, maybe probes that could have detached and potentially targeted Mars. The analysis is ongoing.
Okay, so Mars data is pending. What's the next big date?
October 29th, 2025. That's perihelion, when it ducks behind the sun. That's the prime window for a potential maneuver.
And if it does change course while hidden,
A significant velocity change, maybe 30-40 kilometers per second, which, remember, could be powered by that gigawatt-level source implied by the WOW signal, could potentially put components or probes on a trajectory to reach Earth.
When would they arrive?
Calculations suggest late December 2025 or early January 2026.
so a potential arrival window early next year. If a maneuver happens this fall, are there any other eyes on it soon?
Yes, thankfully. The European Space Agency's JUICE spacecraft, currently heading to Jupiter, will get a look at 3I Atlas in November, just after perihelion.
When it's maximally heated.
Exactly. That data could be incredibly valuable for understanding its core structure and composition after its closest solar approach.
Yeah.
But we probably won't get the process data back until early 2026.
It really highlights a major gap, doesn't it? If something is detected, whether it's Atlas changing course or probes appearing we have no plan.
Absolutely none. There's no established international protocol for how to respond. How do we classify it? Who decides if we try to communicate? Is it a threat? We are completely unprepared institutionally for confirming we're not alone, especially if the confirmation comes via a level 4 or higher object.
So wrapping this up, we're basically watching history unfold. We're faced with either the most statistically stacked deck of coincidences ever recorded in astronomy.
A comet that just happens to align perfectly, arrive at the right time, hide at the right moment, have headlights, be unexpectedly massive, and possess impossible chemistry.
Or it's an interstellar visitor that potentially signaled its approach 48 years ago and is now actively maneuvering within our solar system.
It's a stark choice. And it forces us, you, everyone, to confront that question. What if we're not alone? And what do we do when the evidence becomes undeniable?
It challenges everything. And maybe just one final thought to leave people with, something slightly different. We talked about the anomalies possibly indicating technology, but 3I Atlas is thought to be incredibly old, maybe 7 to 11 billion years old, potentially formed long before our own solar system.
Ancient, yes. Primordial, almost.
So what if the strangeness, the weird chemistry, the fixed orientation, the immense mass, isn't a sign of technology as we imagine it, but simply a sign of extreme age and exotic origin?
You mean, what if objects formed in the very early universe or around very different types of stars simply don't behave like the relatively young comets we're used to?
Exactly. What if its anomalies are just characteristics of a type of natural object so ancient and formed under such different conditions that our current models just can't comprehend it yet?
That's a fascinating possibility, too. A truly primordial relic. Whether it's that or something manufactured, either way, 3 Atlas is forcing us to expand our understanding of what's possible in the universe.
A revolution in thinking, one way or another. That's all the time we have for this deep dive. Stay curious.